Okay, here we have some kind of A-level statistics paper from 2019. And it says 3 bags, I've got to get my pen out, 3 bags, A, B and C, each contain 1 red marble and some green marbles. So bag A contains 1 red marble, 9, etc. Sasha selects at random 1 marble from bag A. If he selects a red marble, he stops selecting. Okay. If the marble is green, he continues by selecting a random one from B. If he selects a red marble, he stops. If the marble is green, he continues by selecting a random one from C. Draw a tree diagram representing this information. Okay, so the way it works is, this is the problem with my life, is so we've got green and red. So green, red, there's 1 red marble, so it's 1 out of 10, and there's 9 green marbles. So if he selects a red one, he stopped. If he selects a green one, he continues, and that's green, that's red. So there's a 1/5 chance there, and then there's a 4/5 chance there. So again, he stops if he gets the red. So that's R, G, and then that's 1 out of 3 and 2 out of 3. So that's the tree diagram. There you go. Find the probability he selects 3 green marbles. Well, so that's A. It's not the best tree I've ever drawn, but we'll have to do. B, green marbles, 3 green. Well, that's going to be 9/10 times 4/5 times 2/3, which is 10 times 5 times 3 is 150, and 9 times 4 is 36, 772. I think I'll leave it at that. Could make it 36 over 75, but in fact I could make it completely. I imagine that divides down by 9, doesn't it? Oh, who cares? It's probability, I can leave it like that. So it's a little under half. Find the probability that Sasha selects at least 1 marble of each colour. Okay, so it goes... well, there's only one way that can happen. It's this way. At least 1... Oh, no, there's 2. There's that one and that one. So it's that one and that one. And then there's that one, and that one. So it could either be 9/10 times 1/5. And then you could be plus 9/10 times 4/5 times 1/3. And that is how... Because if you went down that one, if you went down this one here, he wouldn't be able to do it. If he went down the R, he'd have to stop. So if he goes G, then he goes R, that works. And if he goes G, then he goes G, then he goes R, that is still at least 1 marble of each colour. So we've got 9/50 plus 36 over 150. I realise I could just do this in a calculator, so that would be 27 over 150 plus 36 over 150, which would be 63. There we go, and well, it's just 21 over 50, but we won't worry about that. And then given that he selects a red marble, find the probability he selects it from bag B. So this is A. Hang on. This is A, this is B, and this is C. So, given that he selects an R... Okay, so let's look at all the chances that he selects an R altogether are... oh, this is the problem with doing A-level. Is that you have all of the things, the ways he can get... all the ways he can get R. So, on the bottom of this, you're going to get 1 over 10, because that's him getting it at the beginning. Then plus the second way of him getting R, which is 9/10 times 1/5 plus whatever the last one is, 9/10 times 4/5 times 1/3. I am going to use a calculator for this, by the way. And then the chance of him getting out of B is 9/10 times 1/5. So it's going to equal, here we go. Right, so that's make a big thing. So on top I've got 9/10 times 1/5, and on the bottom I've got 1/10 times, I'm sure actually it'd be easier to just do this, no, plus, delete, so plus, and then it's 9/10 times 1/5, which, let's just face it, is 9/50, so I'll just put that in, plus 9/50, and then the last one is plus 36/150. Although weirdly, 36/150 equals 9/26. So that all equals 9/26. So that's about finding what you can and can't do. Right,